Guys, look, we have a patient on the table. It's a pure sine wave inverter that doesn't work. Oh no. And for those that have already noticed where the problem is, I'll go into it in a few minutes, but the patient that we have today is a Samlex SSW series 2000 watt pure sine wave inverter. 12 volts DC is the input section, and 120 volts AC is on the output. And what you're seeing is the majority of the disassembly of this model inverter. Received it from a fellow YouTuber. Asked me if I'd be able to try and fix it, so I accepted the challenge. And this is what brings me to the first video in a series of videos to hopefully get to the bottom of the issue that this thing is having. He had told me that it released the magic smoke one day during camping and just quit working. Now I know Samlex to be pretty reliable inverters, and the initial go-through before off camera here it's actually built pretty well. There's a lot of through-hole mount components, but it doesn't seem to be built cheaply. Some of the parts here, and I'll go through this in a few minutes, that it looks to be in pretty good shape, and the first video here is going to really be determining and sizing up the job here, and I kind of know where I need to start. And just to give you an idea, and this is a shout out to NeuralNar. I'm really going to be looking to some of your videos again as a roadmap to start doing some diagnosis on this. But from an electronics background that I have, it doesn't really seem too hard to figure out what's going on here. As you might have already seen initially in the video, the input stage MOSFETs have one of them decided to catastrophically fail. Yeah, and that seems to be the catalyst of the problem, at least for the initial assessment. From what I can see here and from what I can read on the board here, there's 24, there's 24 MOSFETs here. When I say 24, I mean there's 12 here, and there's actually 2, 4, 6, there's actually 8 of them here, and then they actually consider these the other MOSFETs. I believe these are the MOSFETs for the output stage, and then here are the 4 diodes. I guess these all make a bridge rectifier here. So those are the diodes. And there's a lot. We have our step-up transformers for the boost stage, and it looks like they use pretty heavy wire here. All goes back to the negative bus, and then you have a bus bar for the positive rails, which go to some 30 amp fuses. There's 10 of them. Now the only thing I'm already off the bat not liking about this inverter, if you can see it, and I'll try and get a good picture as I can. These fuses are soldered directly to the board. So I would imagine if one of these input FETs decided to go, it probably either pulled too much current and shorted out, it probably pulled too much current and blew out one of these fuses. So it's not going to be as easy as I wanted it to be for changing out the fuses. Now I don't know why the manufacturer does this. You figure if it's a replaceable part, being a fuse, but if it's soldered to the board, maybe there's a legit reason. I don't know why. I think it's actually very much a pain in the ass to go and change it this way, but I have the tools nonetheless to fix it. As far as smarts go, we don't have anything out of the ordinary. It looks like this board is meant for the low voltage alarm, and it's the only parts in the board here that are automated. There's a lot of surface mount components there, and I'm going to try and focus in on it. There's quite a bit of there's a lot of diodes, and I see some very small, let's see, there's a couple transistors on there, obviously a capacitor, and then over here is probably the drive circuitry. Now I got to figure out which is which. One might just be for the features that there's a remote that comes out of here out of the Cat 45. That might have to do something with this board, and I believe this has the drive circuitry. And the good thing is that I can read the parts that are on this board, so I would imagine that this is where most of the smarts and the drive circuitry are located. And thankfully I have the hot tweezers, the special tools to remove SMD components if anything is burned on that, but I don't think I'm going to need to go that far. I mean, there's nothing else as far as smarts go on the board. We have, let's see, you got an IC here. I got a VR2 pot adjustment, and there should be there's a VR1 there. I don't know if that's for output voltage or if it's for biasing the input-output stage, so I may not want to mess with that too much. If it's just the input stage MOSFETs that shorted out and it didn't take out anything else, which I'm kind of hoping it didn't do that, we should be in good shape to get this thing back going again. But then again, I don't know until I really start digging into it. But it's pretty, believe it or not, it's actually pretty basic. The only complex stuff is obviously the drive circuitry, maybe some of the features for the remote control, and then the low voltage alarm over here. So that's really the only most complex stuff that might be a little bit beyond my ability, not because I can't perform the work, but I would be kind of flying blind without a schematic, and I highly doubt that Samlex would be willing to provide me with a schematic unless I was an authorized dealer or something like that. But the challenge is now to figure out why it's not powering up at all, and to see if we can get it running again. So the first step into figuring out how to attack this problem is, I think I'm just going to replace the entire bank of input MOSFETs, and it's probably the best way to go, considering that if one failed, it's only a question of asking Murphy's Law when the rest of it is going to, when another one of these things is going to go. So they can't be that extremely expensive. I figure I order those. These are part of the output stage. These might be a couple more dollars, but it can't be that bad. The diodes are, I don't see any numbers on them, at least not without a magnifying glass. But I'll take a look at those. They're probably pretty standard diodes that I can use. 600 volt PIV. Maybe they might be a 2 amp maybe, or maybe less. That might be, I'll have to look into that a little bit more, but it's certainly doable. The input capacitance looks pretty good. They are 16 volts, 4700 microfarad capacitors. You have 4 of them here. And then you got 1, 2, 3, 4, 5, you got 6 of them over here. So so basically 2 capacitors for every transformer, and that's pretty good. I would have much preferred to see a 25 volt rating, but then again, this is a mass-produced inverter. I forget the exact sell point that this is at, but it's not that bad at all. And if I can, I'll move the camera here a little bit to show you the underbelly. Alright, well here's the underbelly of it, and as expected, those big solder blobs are actually where the fuses are, so it doesn't look too insane to get those out of there, but it will still be a little bit more operational work to get them off. I think that's just more annoying. They really should have those socketed, and I'm not going to be able to focus this too well on, guys, because it's so close. I probably need to get my macro lens, but that's where that particular FET failed. The trace still looks intact, so that's a good thing. Then you got the little pads here with the little, there's like a plastic sheath to prevent it from grounding out against the case. And it looks like there's some resistors put on the bottom here. And then obviously those circuit boards are, let's see if I can focus in a little better. You can see how those are put into the board there. Looks like they wouldn't be that hard to remove safely, but again, it's something that I hopefully don't have to go that far. And everything seems to be in place. Nothing else melted or burned or anything, so I'm hoping it's just the input section that I need to replace. So this is going to conclude the initial video for right now. I think what I'm going to do now is find the part numbers on the MOSFETs, and then order some diodes, get the part numbers off of this, and order them off of from my supplier there, and at least start with that. I might just go ahead and order some of these parts are very, very inexpensive, and might just go ahead and at least get some of the smarts here, like that U1 optocouplers usually don't tend to go capacitors unless they're actually exploded. You don't really need to worry about them so much, but at least as for an initial test here, and not necessarily throwing parts at it and see if it'll work, but I think I got myself a good indicator of where to start for sure. So this will be a to be continued, and I will give you guys an update once I've gotten my parts and start to add the replacement parts to it and see if it powers up or not.